All right, hello folks, and thank you so much for joining us for our session today. My name is Andrea. I'm your room host today along with Edgar in the back. Just a couple of quick housekeeping items before we get started today. Did want to call out that we do have emergency exits on both sides of the stage, in addition, of course, to the main doors in the back. If you do need to use the restroom at any point, there are restrooms out the door on your right. Also, if you haven't done so yet, we do encourage you to download the mobile app. You will have the opportunity after the session today to submit your feedback via a survey. So again, please download that app if you haven't already. And then also want to remind folks that we are recording the session today. So that recording will be available after the event. All right, with that being said, we will go ahead and get started. Our session today is Improve the Developer Experience with AWS CDK. And I'd like to welcome to the stage our presenters. We have Casey Lee, who is CTO of Gaggle. And then we also have Galen Dunkelberger from AWS.
Can I leave this off? So what does a good developer experience feel like to you all? For me personally, it's that moment when I can focus on the business problem at hand and not be distracted by the ceremony of the tools and the platform that I'm developing for. Now, sometimes this is difficult to get into this flow when you're developing for the cloud, because you not only have to think about the application that you're building, but also the infrastructure that you're going to run it on. Now, I've seen some teams try to reduce the mental burden on their developers by transferring this responsibility to a cloud infrastructure team. Now suddenly, projects start to become very waterfall-esque as developers are tossing code over the wall for another team to deploy. During this session, I hope that we can show you how the AWS Cloud Development Kit can help you as developers deploy your own infrastructure to run your applications in a way that feels more natural and keeps you in a good developer flow. So good afternoon, everyone. Thank you for joining us for USE 301, Improve the Developer Experience with AWS CDK. My name is Galen Dunkelberger. I'm a solutions architect with AWS. I've been a developer for almost 19 years, and during that time, I've had the chance to experience both good and bad developer experiences. Today, I help enterprise ed techs find new and innovative ways to service their customers using AWS. And joining me today is Casey Lee. He's the CTO at Gaggle. Now, Gaggle's an ed tech whose mission it is to ensure the safety and well-being of students in schools by leveraging people and technology. So over the next hour, there we go, got it. Over the next hour, we're going to give you an overview of what the CDK is and what it does. And then we're going to dive into what some of the challenges are as you as cloud developers face and how the CDK can help you overcome those challenges. And hopefully we'll share a few best practices along the way. And then later, Casey's going to come up here and talk about how Gaggle's developers leverage the CDK to improve their agility, release features faster, and all while keeping better tabs on their development costs. So the Cloud Development Kit, what is it and what does it do? Now, when we look at customers, we usually see them fall somewhere along this line as far as how they provision their cloud infrastructure. So maybe some of you are just using the console and manually provisioning your cloud infrastructure. And this is fine. You're able to get up and running simply and easily in a few minutes. Others of you may be using scripts and using the AWS CLI to provision your infrastructure in a more reproducible manner. Now, still others of you may be using cloud infrastructure provisioning engines like CloudFormation or Terraform. Now, these tools are great because they hide a lot of the complexity around state management, drift detection, error management, and rollbacks. And you as developers can describe the infrastructure that you want to provision and then provision it in a way that is consistent. The problem is that as these templates become as these templates become more complex, you start to see they become more difficult to maintain. And so we often see like one developer on the team sort of become the CloudFormation guru, and they spend all of their time writing YAML instead of writing actual application code. So developers being developers, we like to write code, and so we end up creating or adopting, generators, things like troposphere or GoFormation. And these allow us to write CloudFormation in code and then generate the YAML or JSON template. Now, before I joined AWS, I was on a development team, and we did something very similar to this. And when we came to our solutions architect back in 2019 to show him what we had built, he was like, oh, that's cool. But actually, we just released a new tool called the AWS Cloud Development Kit. And I think it could help you out. And we were like, well, what is that? And we found out that the CDK is actually a multi-language software development framework for defining and provisioning cloud resources in code. So instead of writing YAML or JSON, you're writing code. Now, we think the CDK offers developers a number of benefits. The most important is you get to work in the language that you're already familiar with. No need to context switch over to declarative JSON or YAML when defining your application infrastructure. Now, because CDK is just code, you get to use your IDE and all the great features that are available. So things like code completion and inline documentation. And with CDK, you can create abstractions of your infrastructure, and the framework itself, I'm sorry, a little bit behind there. The framework itself provides sane defaults that allow you to get up and running quickly using the framework. So let's take a quick look at the components of the CDK. First, we have the core framework. Now, the core framework allows you to create applications that contain one or more stacks. Now, stacks are these logical units of infrastructure that can contain one or more resources, things like S3 buckets or Lambda functions. And these stacks map one-to-one to CloudFormation stacks. Now, the next component is the CDK CLI. And the CLI helps you interact with the core framework by generating your project infrastructure, by allowing you to diff what your deployments are going to be, and allowing you to quickly deploy to AWS. And finally, we have the AWS Constructs Library. Now, this is a set of components crafted by AWS to help you quickly create resources for specific services. So let's look at the workflow for a typical CDK application. So you install the CDK on your local machine, you fire up your favorite command line terminal, and you type CDK init, and you specify the programming language you'd like to work in and the type of project you're going to create. Now, this will generate the shell of the project for your specific programming language, and now you can get started creating apps, adding stacks, and creating constructs and resources. After that, you're going to have to build the project. So in the case of TypeScript, you're going to run npm run build. And this is going to do all the type checking that your programming language does and make sure that the code actually builds. Now, next, you have to synthesize what's called the cloud assembly using CDK synth. Now, the cloud assembly is the creation of CloudFormation templates along with the packaging of runtime assets that will be deployed to the cloud. And you can see what changes will take place when you deploy this cloud assembly by running CDK diff. And this will show you what will be updated, created, and deleted. And then finally, you can run CDK deploy. This will push the changes into AWS CloudFormation and will deploy the infrastructure resources into your AWS account. So the AWS Constructs Library represents resources that are available on AWS. And this is a great starting point for creating resources, but the real value starts to come in is when you start composing these resources into complex infrastructures, things like network setup, compute clusters, databases, and full applications. Now, the constructs are split into 3 levels. Level 1 constructs are automatically generated using the CloudFormation specification language. and they map one-to-one to AWS resources, and they all start with a CFN prefix. Level 2 constructs are higher level constructs that represent things like an S3 bucket or a VPC, along with supporting resources. So a single construct may actually generate multiple resources, but they're all focused on a single service. Now, these constructs are often easier to use than level 1 constructs and can generate really complex cloud formation with very little input. Finally, we have level 3 constructs, and these are opinionated abstractions that often combine multiple services to support some sort of function. So think of API gateway, Lambda, Dynamo as a REST construct that you might build. Now, these constructs are developed by AWS and third parties within the CDK community, and this is where you would want to focus your efforts in creating your own constructs for use within your organization. So I'm still there. When we look at CDK versus cloud formation, we really see this paradigm shift towards you, the developer, right? Instead of having this rigid declarative template, we now have a dynamic and powerful object-oriented structure. And what's more is that the CDK apps can actually deploy to multiple environments. So typically with a cloud formation template, you're going to have one template, and you're going to pass in different parameters for the environment, right? With CDK, you can actually define all the environments that you're going to deploy to, and those will generate different different cloud formation stacks. So you can do sort of neat tricks like have less expensive resources for your test and dev environments as opposed to your production environment. All right, now that we've all baselined what the CDK is and what it does, let's talk about how it actually helps you, have a better developer experience on AWS. How many of you who have done sort of on-program deployment or on-prem deployment and then moved to cloud deployment were initially like, where the heck do I put my infrastructure as code? Cool. Like, does it go in its own project? If so, how do I keep it in sync with my application? Does my build deploy it? Does my CI/CD pipeline deploy it? Do I test it? It's written in YAML. How do I test it? So one of the most satisfying things for me when I fire up a new CDK project is that I don't have to worry about any of those questions. I know that my application infrastructure is going to live right next to my application's runtime code. I'm going to evolve the two together. I'm going to test them in isolation together, and I'm going to check them into version control together because it's all just code. Now, this takes away the mental burden from having to sit here and go, okay, I'm now programming in an imperative language for application runtime code. Stop. Now I'm defining the infrastructure that application will run on in a declarative language. The other advantage of putting these two types of code together, application and infrastructure code, is that it simplifies deployments. So I told you how when you run CDK synth and CDK deploy, not only does it generate the CloudFormation template, but it also packages runtime assets. So on the screen here, I have an example of a construct where I can create and deploy a simple Lambda function written in TypeScript. Now, when I run CDK deploy on this, it's actually going to fire up Docker, run ESBuild, bundle that code together, and then upload it to an S3 bucket, an assets bucket, generate the CloudFormation template that will then reference the runtime code in that S3 bucket. And the whole point of this is that I don't have to worry about how this is getting deployed. I can just focus on writing the code for my Lambda function. And this keeps me in a better developer flow. I don't know what IAM policy I need to make this work. Anybody ever said that? Cool. Writing good least privileged IAM policies is difficult, especially if you're new to AWS. Each AWS service can have its own actions, resources, and condition context keys that can be used for IAM policies. This makes it difficult to know exactly what combination of actions and resources need to be applied in order to achieve the desired result. And so a lot of times what we'll see developers do is just kind of apply a wide open policy like this and, hope for the best, right? And what are your choices here? Like, you have to stop, get yourself out of the mindset of coding, go figure out what IAM policies need to be applied, and then come back, or, release code with too permissive of a policy. And here CDK can help. CDK provides the grant convenience methods, and these allow for the quick and simple creation of IAM policies that grant only minimal permission for the selected function. So least privilege is a good thing, right? And it's going to help your next code review or security review go smoother because you're leveraging the security best practices that AWS has baked into these methods. But what I like even more about this, that's great, but what I like even more is the fact that, I can just start using my IDE's code completion to find out exactly what permissions are available on each resource. And this is so much more intuitive to me than going and sort of looking up, okay, well, what S3 or what IAM policies do I need to apply here? I can start typing grant. I get a list of logically named functions that I can choose to apply the permissions that I want, like read or write access. Now, when we look at what the output of one of these grant methods actually is, for instance, here we have a grant read method being applied on an S3 bucket. We can see that it generates multiple lines of CloudFormation code and it applies, multiple actions to that IAM policy. Now, this has saved us time from having to figure out not only what those permissions are, but writing the actual CloudFormation code. And as an added bonus, when you type CDK deploy, you're going to get this nice report of exactly what IAM policies are going to be applied for what roles to each resource, right? So you can take a look at that and see, yeah, this is exactly what I want to do, and accept the changes or sort of back it off. Again, here CDK is saving you time and making your code more secure, all while keeping you heads down in the code base. Next challenge. Anyone ever pray this prayer on a Friday afternoon before deploying? Look, we all know mistakes are made, and that's why we have automated testing frameworks to let us know that a change we've made somewhere in our code base had unintended consequences elsewhere. And chances are you are all using some kind of automated testing framework to test your application code. But now, because CDK is just code, you have the opportunity to write tests for your infrastructure code using your favorite testing framework. Now, this might seem a little weird initially, but remember, your infrastructure code lives with your application, so why not test it? Now, there are 3 different types of tests that you can apply: snapshot tests, fine-grained assertions, and validation tests. Now, snapshot tests test the CDK generated AWS CloudFormation template against a previously generated baseline. So these tests are a great way to make sure that you're fully aware of all the changes, the effect of a change that you made to your infrastructure code. They're extremely low code, so you should use them. This is the typical, although my little offset here with the screen, but this is a typical snapshot test. Now, when I run this test, what's going to happen is if I don't already have a snapshot created, it'll create a snapshot, store it in a file next to the test, and the test will pass. Now, those snapshots that are created should be checked into version control. Now, the next time I make a change to this infrastructure code and I run the test suite, it's going to fail, and it's going to show me exactly what changes were made. And if those changes were expected, great. I can update the baseline, the tests pass again, and I can move on. Now, the next type of tests are fine-grained assertion tests. And fine-grained assertion tests test specific aspects of the generated AWS CloudFormation template. So things like, this resource exists with these properties, with these values. These are more like your typical unit tests, and I tend to use them to make sure that critical infrastructure is generated and configured in the way I expect. So I have a very simple example here where I'm checking to see, yep, I've generated an SSM parameter under a specific name, its type is string, and it's in the standard SSM parameter tier. Now, if any of those things is untrue, the test will fail, and I'll know that something's wrong. And finally, we have validation tests. Now, validation tests help you fail fast by making sure your AWS CDK constructs raise errors quickly when fed invalid data. So imagine you're creating a dead letter queue construct, and you want to ensure that the retention days for that queue don't exceed 15. So you define the properties for the component, you define the construct itself and put in your validation logic, and then you go and write a validation test where you purposely pass in invalid data to make sure that that error is thrown. Now, these types of tests lead to high-quality custom constructs that ensure that your end user, the end user of your constructs, who are typically your teammates, have a good developer experience by getting a solid feedback loop and seeing these errors quickly. Now, the point of all of these tests is to allow you to evolve and refactor your application and its infrastructure code confidently, right? So it's wonderful to come to a piece of code that you wrote 6 or 12 months ago, fire up that make a change, fire up that test suite, and see that green bar. That's going to help you have the confidence to deploy more frequently, and to me, that is a good developer experience. Next challenge. Congratulations. You've done it. You've deployed your application, you've tested it, and it's in production. And your manager comes up to you and says, "Good job. How do we know this thing is working?" And that's when you have to explain that, well, we didn't really have time to build a CloudWatch dashboard for production, but we'll totally make that the top priority next sprint. Monitoring the health of your application and its infrastructure is key to achieving operational excellence. By adding monitoring, you help your future self, you do your future self a favor by being able to proactively identify problems and mitigate those problems before the customer sees them. But I get it, other priorities take precedent, and so wouldn't it be really nice if, as you're defining your infrastructure as code, you could just define the CloudWatch dashboard right there. And that's exactly what the metric convenience methods help you do. Much like the grant convenience methods, you can use your IDE's code completion to figure out what metrics are available for each resource. And then you can add those metrics to a widget. So in this example, I have an API a gateway here, and that I want to add an API latency widget. So I create the widget. I add average latency, P90, P95, P99 statistics, all in 8 lines of code. Now, if any of you have ever tried to create a CloudWatch dashboard in CloudFormation, you probably know it takes more than 8 lines of code. So here again, CDK is saving you time and increasing your level of operational excellence. Next challenge. Have any of you ever had finance come to you and ask for a cost breakdown of your application's infrastructure? Or have you ever had to, have an inventory of all the infrastructure resources your application uses so that you can develop a DR plan? Do you know what would have helped you during this, perform these tasks? Tags. But when I talk to teams about their tagging hygiene, a lot of times I hear this message. We tag our resources sometimes. CDK provides a mechanism for easily applying tags to constructs and all of their taggable children. So this means that in this example, I can apply tags to all of the taggable resources in my stack with just 1 line of code per tag. Now you're probably thinking, that's great, Galen. I'm glad that it's easier to apply tags, but I still am not able to apply my tagging standards. And I'll say, actually, what's interesting about the CDK.tags class is it's an example of an aspect. So aspects are a way of applying an operation to all resources within a specific scope. Now that operation could do things like modify those resources, like adding tags, Or that operation could be doing things like verifying the state of those resources, like making sure a tag exists. So in this example, I have a simple aspect created that checks to see that the cost center tag is applied to all taggable resources. I can apply this aspect with a single line of code. And when I run CDK synth, it's going to let me know if any of those resources are not tagged correctly. So in this case, I had the wrong casing for cost center. So for example, CDK aspects not only help you with tags, they help you with so much more. So we all want to adhere to development best practices, as long as doing so doesn't take a lot of effort to figure out what development best practices we're missing. One such project that's available out in GitHub helps with exactly this problem. It's called CDK NAG. Now, some of you might be already checking your CloudFormation templates for AWS infrastructure best practices using a project called CFN NAG. Now, CDK NAG is inspired by that same project, and it uses aspects to check all of the resources within your CDK application for AWS infrastructure best practices using one line of code. So you apply the aspect to your CDK application, you run CDK synth, and you get this nice report of all the resources that don't adhere to AWS best practices. So here, again, CDK is helping you apply tags, enforce tagging standards, and enforce best practices. Now, if you haven't had a chance to check out CDK NAG, I highly recommend it. Next challenge. Have you ever wanted to share a piece of infrastructure code with another team in your organization, and then you realize, I've got other priorities here. I'm just going to cut and paste some YAML or JSON into Slack and call it a day. Now, there are totally good ways to share declarative infrastructure as code, things like CloudFormation Registry and Terraform modules. But as developers, we're already used to sharing reusable components as code libraries. And here again, CDK helps us. Now, when you're modeling your infrastructure as code, you really should try to model in terms of constructs and not stacks. Stacks are units of deployment, and they're often focused on a specific application and in a specific environment. When you model your infrastructure as code using constructs, you give yourself the potential for reuse of those constructs, either within the same application across different stacks, or outside your application as part of a published construct library. Now, in order to implement this opportunity for reuse, we recommend that you organize your code so a single team will have ownership of one or more code repositories. And within those code repositories, there should be one or more packages. Now, each package contains one CDK app. So you start developing the app, and you find that, I've come up with a construct that's going to be really useful across other applications for other teams. That code should be pulled out into its own package within its own code repository with its own development lifecycle, and then shared via an artifact repository such as Code Artifact. This way, other CDK apps or constructs libraries can import your library as a dependency. But before you go and do that and sort of create your super organizational constructs library, take a minute, stop, and visit the constructs hub at constructs.dev to make sure that there's not already a construct that meets your needs. The constructs hub is a central repository for CDK constructs developed by AWS and third parties of the CDK community. And they're there to help you be more efficient as a developer by not having to reinvent the wheel for common design patterns. One such construct that's available is called CDK pipelines. Now, I'm a big believer that development teams should run and manage their own CI/CD pipeline. You're closest to the project, and you know what you want your pipeline to do. But the problem is that, managing a complex CI/CD pipeline is time-consuming. The CDK pipelines construct allows you to get up and running with a fully managed CI/CD pipeline in a matter of minutes. And the code that defines that pipeline lives within your project. So now you have infrastructure code, application runtime code, and CI/CD pipeline code all living together in the same project, evolving together, and versioned together. Last challenge. This isn't CDK specific, but it's definitely going to improve your developer experience on AWS. Have you ever been in a shared AWS account with multiple developers and either deleted somebody's resource or modified somebody's resource or had the same done to you that messed someone up? My man. Yeah, it's totally possible for multiple developers to work within the same AWS account, but developers can work so much quicker if they're all given their own development account as part of a good multi-account strategy. Now, talking about multi-account strategy is way beyond the scope of this talk. We don't have enough time, but here's a really quick overview. Each developer gets their own development account where they can deploy their CDK application, test it, and develop new features. When they're ready, they check the code in to Team's source control repository. And that check-in triggers a CI/CD pipeline to run in a shared team account. Now, the pipeline runs the tests, builds the application, and pushes it out into lifecycle accounts for further testing and eventually to production. This has two benefits. One, you're not stepping on each other while you're in sort of the frenetic mode of development. And two, deployments to other accounts are controlled through source control and the CI/CD deployment process. And now, Casey's going to come up and tell us about how Gaggle's developers overcame some real-world challenges using the CDK. Casey?
All right, thank you, Galen. My name is Casey Lee. I'm the Chief Technology Officer for Gaggle. Gaggle is an ed tech company that builds software that school districts use to protect the students while they use the school-issued Google or Microsoft accounts. And the way this works is Gaggle ingests all of the content that the students are creating with the school-issued accounts, and we have a series of automation that evaluates the content and ultimately a series of machine learning models that make recommendations on when we need humans to get involved and review the content. And in the case of situations where there might be harassment or bullying or signs of self-harm or even suicide, we then notify the school district. School district gets the students the help they need just in time. What I'm showing on the screen here are some numbers from what we saw in our systems during the last school year, the 2020-21 school year, during COVID and distance learning. And what you see here is the significant impact that distance learning had not just on our traffic, but also on the mental health of the students that we protect. We saw a 490% increase in the number of files that we were processing, over 6 billion files in that school year, over 5 billion messages, up 350% from the previous school year. We then had over 38 million items that we had to review manually as humans that the ML models detected as requiring human intervention, up 34% from the prior school year, resulting in over 142,000 cases of suicide or self-harm being discussed by students, up 87% from the previous school year. Of those, there was over 1,300 incidents of what we call lives saved. And a life saved is a situation in which we see an imminent threat where a student is having suicide ideation and plans of acting out in a very short period of time. We get the school district involved, they get the help, and those were the number of students that we were able to save in the past school year. Now you can imagine with dealing with this volume of data and this characterization of data that there's tons of technical challenges. Now fortunately, we were on the AWS cloud when COVID hit, and we were able to scale up and handle this load at the time when the students needed it. But there was other challenges that we've found as we've invested in AWS, and that's really what I want to spend some time talking about today. When I would ask people inside the tech team or outside the tech team at Gaggle, how are we doing, I would get this message that the tech team never gets anything done, and when they do, it's months late. And this isn't a unique problem to Gaggle. This is a problem that tech companies have all over the place. But we really wanted to address this because we felt that we owed it to our customers to make sure that we were able to remain agile and build at the pace that they needed. So we started digging into this. And the first recognition that we had was that this was not a people problem. Gaggle's engineers are some of the brightest and best that I've had the privilege of working with, and they're extremely dedicated to the mission and hardworking. So if it wasn't a people problem, then what was the problem? And so we started digging into Jira, which is the tool we use to keep track of our tickets, and we found that we had a trending upwards lead time, the time from when a ticket would start until it would finally get into production, at its peak of 47 days from when work started till when it would hit production. And all the while, we saw developer efficiency decreasing down to about 12%, which is showing that at any one point, the amount of work that's in the in-progress state, only 12% of it's actually being worked on. Okay, so that's an important piece of information. Why was there so much work in progress that wasn't getting worked on by engineers? So we started digging into that, and what we realized was that the developer experience was poor. And so the reason why was looking at this picture on what the developer's flow was. If you start in the top right, a developer could pull down some code and start doing some maybe unit testing of the changes they would make. But because we were so invested in cloud-native resources like Lambdas and Kinesis streams, DynamoDBs, SQS they couldn't run this stuff locally on their laptop. And we had a shared staging account. And so the only way for them to validate their changes was to create a feature branch, send the request to QA. QA would then, we were using Bamboo, use Bamboo to deploy that feature branch to the staging account. As you can imagine, this resulted in a developer experience where feedback time would take days, right? We want that down in minutes. As a developer, you want to get feedback in minutes on how your changes are working. So we realized this was a huge problem and affecting our WIP because developers, they don't want to sit around and wait. If this is going to take 2 days to get feedback on, fine, I'll pull another ticket and get started on it. So we recognized that our problem was this feedback cycle. So what did we do? Well, easy answer, we used Control Tower, gave everybody their own development account, that's it, I'm done, right? Now this created a whole bunch of other problems. But we did this, we gave each developer their own AWS account, Control Tower was great for that, and allowed them a place to get feedback independent of each other. But the problem became, how do I actually deploy my application into my development account? Great, you gave me this new account, but how do I use it? Previously, they used Bamboo to deploy to a single environment. And all of the infrastructure code was spread throughout Bamboo scripts and some other DevOps repos that the devs didn't have access to. So they couldn't easily deploy their code to their own account. So our solution to this was we started investing in CDK. What we did was we wrapped each application we created a CDK app for each application. We put the code for the CDK app in the same repo as the application that was being deployed. And in some cases, we didn't have the time to go through and actually create all of the native CDK. So we would just import existing CloudFormation templates. We would create the shell of a CDK app, import the existing JSON or YAML, and then we now have the ability to have all of the code necessary to deploy an application inside the repo where the app is as well. Here's an example of a CDK app. We chose to use Python, so if this looks a little different from earlier, we're just changing it up on you. So we use Python, and this is an example of a stack that deploys a single-page application, an Angular app, as an S3 website. So we started creating some higher-level constructs that were then shared in a third-party pip module called Gaggle CDK. Gaggle CDK had this higher-level module called S3 website, where you just pass a couple attributes in, what your Route 53 hosted zone is, and a path to your source code in your local directory. And then it takes care of creating the bucket, configuring it for web hosting, creating the CloudFront distribution, creating the ACM cert, and the Route 53 record sets. Everything the dev needs to get their code deployed as a single-page app. And then we also created constructs like you see here, S3 JSON file. This was a way to take outputs from some of the other CDK constructs, create a JSON file with those outputs, and then upload that as an object in S3. That way, think about it like your environmental data. So we could load our environmental data dynamically for each application. So this was great. We were creating these higher level constructs, and devs were starting to use them to build out their applications. Another thing we did was we needed a way to address our least privilege challenge. So we gave devs their own AWS accounts, but they didn't have admin access in those accounts. They had a limited set of access to deploy the things they need. But in order to deploy things like Lambda functions, they also need to be able to deploy IAM roles. And a concern was, how do you allow someone to create an IAM role without privilege escalation, where they create a role with admin access and then assume the role and you can do whatever you want. So AWS has a nice technique for this called permission boundaries. And so with a permission boundary, we were able to grant access to create roles in the account so long as they always attached a predefined managed policy as a permission boundary to that role. This prevented privilege escalation. Now, this can be painful when writing CDK to have to go through and attach that to every single role, especially when you're using other higher level constructs that create roles behind the scenes that you don't even know about. So we created an aspect that is just a function called apply permission boundary. You run this against your a stack or another construct, and anything below that gets the permission boundary automatically applied. Make it easy for the developers to do the right thing. Another thing that we needed to do was enforce tag policy. So we have service control policies set at the organization level on all these member accounts that certain tags must exist on every resource that's created. So we created a Gaggle tags construct that makes it easy to apply those necessary tags on every resource down throughout the stack. So you create this once inside your CDK app, and then you have all of the necessary tags to be compliant and not get permission denied errors. Okay, great. So now developers are able to deploy their application into their member account, but we have another problem. Since we're using microservices, we've got all these other repositories all with their own CDK apps. I've got my own account, and I deploy my own app, but what about the other 12 services that I need? How am I going to get all those running? So what we did here was we wanted a way where we could assign dependencies. So one CDK app and one Git repo could depend on another Git repo. Unfortunately, this isn't a native thing that CDK offers, so we built something. We built something called CDKR, which starts with a YAML file, because no good DevOps tool doesn't have YAML associated with it. And this CDKR tool reads in a small YAML file where you define your dependencies on other Git repo URLs and branches or tags, whatever it may be. And so the way this works, on the left there, you see the YAML file that exists in every repo. On the right is an example run. When I run CDKR deploy, it reads the YAML file, it looks up all the dependencies, and the first thing it does is does a git clone, check out the appropriate ref, and then run CDK on that. If that has dependencies, it'll recursively run through to all the dependencies. So what I can do is I can check out a repo, brand new account, run CDKR deploy, and it'll recursively run CDK against all my applications, and come back from making a pot of coffee, and your account is now set up. New challenge. QA is now feeling the pain. So we've got all these devs with all these accounts pushing all this code, and we still have the same problem where we had a staging account, a single staging account, and there was a bunch of manual testing still happening in that staging account, and now the devs are having fun and they're pushing code, but QA is feeling the tidal wave of load from them. So what do we do about this? More accounts, right? We just start creating more accounts. So we did a couple things. We gave each test engineer their own AWS account so that they could run all of the CDK for branches and do evaluation in isolation of the pipeline. But then we also created separate team accounts. Every team got their own integration account. And that way, if the team needs to do manual testing as a part of their pipeline, that can be done without taking over the staging environment. The idea was staging is not meant for long-lived testing. It is a quick touch and go on your way to production. And the only way to accomplish that was to take all of that out of staging and give folks another opportunity for where to perform those things they needed to do. So separate integration accounts per team helped address that problem for us. The other thing we did was we said, well, let's start creating true CI/CD pipelines for each of these repos. And so the goal was that we wanted each team, which is highlighted in the large boxes on the left, would have their own integration account and a pipeline for each application. When the developers commit code to the main branch on the given repository, code pipeline would run, automatically build and deploy into the team's integration account. All of the automated tests could then run against that integration account, at which point, if all the tests pass and any manual testing that occurs in there pass, we then approve that stage of code pipeline to move on to the next stage, which would be the shared staging environment, final set of tests before deployment into production. And so you have this fan-in effect where we've got all these developer accounts fanning into the integration account, fanning into a single staging account before production. For creating these pipelines, we chose to use CDK. We created a high-level construct that was opinionated on how pipelines should be built. This incorporated things like cross-account roles. We chose a model similar to what you saw earlier, where we had a single toolchain account. That toolchain account then used IAM roles to do deployments into the integration, staging, and production accounts. And so managing all of that, also the management of creating code build projects for each stage of the pipeline, was all made easy for devs through the creation of this thing called a deployment pipeline, which is just a CDK construct. This allowed them to create their own pipelines in their own repo, so they would create a CDK app specific for their pipeline, deploy it alongside their application code, and then provision a pipeline that you see on the right there, which includes all the necessary stages to build, test, and release into the different environments. So this brings up a new challenge. All of these accounts started to get pretty expensive, right? We're giving everybody access to do what they want. It's a lot easier to keep an eye on just 2 or 3 AWS accounts, but 50, 75 AWS accounts, it gets kind of crazy to try to figure out where all the money's going and who's doing what. So our solution to this was creation of budget automation. AWS has a great construct for creating and keeping track of budget control through your master account in the organization. And so what we ended up doing was creating automation that defined a budget per member account. So that's a budget per dev account or budget per team account. These budgets were created in such a way that they had a daily budget instead of a monthly budget. That way we could get immediate feedback on when spending was starting to get out of control. We would then attach an SNS topic to these budgets, and then both subscribe the developer and the manager's email address to these accounts, so they would get feedback. But then also we would subscribe AWS chatbot to the SNS topic, and we would drop notes in Slack channel nightly when budgets were overrun, so that there's no excuse for not knowing that you're spending too much. It gets a little annoying when you're like 10 cents over budget and people start calling you out, but this was great for getting visibility into where our spend was going out of control. So the way we did this was we defined a YAML file that had the budgets, the default budgets for every account in the organization, right? Because we want a budget even if we forget to put a specific budget on the account. So we have a default daily budget assigned, and then we have a Slack channel that gets all notifications for any budgets for the entire organization. And then we could start creating teams. So for example, we have a team called the food team, and the food team, the owner is Alice, and so she's the manager that gets notifications for any member accounts under her team that go over budget. And then we could see that developer Alice and developer Bob are both listed, and we could specify special budgets for them. What's really cool about this is, let's say Bob is doing some work with Redshift, and he's going to run up a really high bill for the next month. Well, we can just create a pull request. This is just a repo that has its own pipeline for deploying budgets. He can create a pull request asking for his budget to go up to $20 a day. Once it's approved, it gets deployed, and we've got a nice history of who allowed that budget to be put in place. Here's a view of what the CDK looks like for defining these budgets. So we have we use Boto 3 to just make an API call against AWS organizations, get a list of all the accounts. Then we iterate over the accounts, and for each one, we create an instance of the account budget CDK construct, pass in what the limit is and the email addresses of who's going to get notified when it's over budget, and then we configure a chatbot Slack configuration and subscribe it to the topic. What's kind of cool is you see here the variable called B is assigned from that account budget construct, and down below at the bottom you see where it says notification topics equals and then an array b.topic. So the topic is created up in the account budget, and then the ARN for it is referenced down in the notification topic. So you see how we're able to chain together different CDK constructs to ultimately yield what we're looking for. What's also nice about this is you're not inventing something new, really. You're just configuring what AWS already has to offer. So you go into the budget console and you can see all the devs and what their current daily budgets are. Just as you'd find things exactly how you'd like to find them. And then here's a view into what a team Slack channel might look like. You show up, and we've removed the names to protect the innocent, but you see what the notification looks like on a daily basis when someone goes over their budget. So what are the results? We make all these changes. We adopt pipelines. We adopt CDK for automating our infrastructure. We change our ways of working. We change how dev works. We change how QA works. What was the impact? Well, we ended up with a new development process that looks like this. Developers are now able to do local testing, as always, run unit tests as they might have in the past. But then they're able to deploy their local changes without having to do commits and running of pipelines. They can just CDK deploy their app straight into their own account. They can deploy dependencies through that CDKR tool that we created. They're able to do remote testing right there against their changes, get fast feedback within a matter of minutes, and then ultimately create a pull request and have a high degree of confidence that that code is going to perform the way they expect. In the middle, you see that our SDETs, our test engineers, they also have their own member accounts. So when they see a pull request, they can check out that pull request locally. They could CDK or deploy it. They can run their own test against their own account. They can build some automated tests against that new branch and then push the automated test right back up to that branch on the PR that's currently out there until they ultimately approve the PR for the developer to merge. Developers then merge the PR once all approvals are in place. Code pipeline kicks in and starts the build off of main. The pipeline then does the building of the software, deployment to a team integration account isolated from the other teams. We perform automated tests against that account, perform manual tests against that account before approving it to then deploy into the other staging and production accounts. And then the real results is when you look at what the last 4 quarters have looked like after we've adopted pipelines. We've seen a huge increase in the amount of deployments that we do. We've over tripled the amount of releases that we're doing. We've dropped our lead time down to 12 and 13 days for the past 6 months. And we've also gotten our developer efficiency from down around 12 to up over 60%. Again, that's a measure of how much work that's in progress is actively being worked on devs. So very excited on the results that we were able to return on this investment in CDK and pipelines and automation, and ultimately help save more students' lives. Thanks.
Thanks, Casey. Well, I want to thank all of you for attending our talk today. Hopefully, for those of you who already have experience using the CDK, this talk has inspired you to dig deeper into the capabilities for improving your developer experience. And for those of you that haven't had the opportunity to use the CDK yet, I highly encourage you to start experimenting and seeing how it can make your development flow in AWS a lot better. Just want to remind everybody that to fill out the survey session for this session, USC 301. I promise you real people at Amazon do look at these statistics and to tailor content for further events. So thanks a lot. Casey and I will be hanging out for a little bit if you want to chat or have any questions. But have a great rest of your conference. Thanks. All right. Cool. Yeah, good job for you, man. Like, that was awesome.